equation, it only gives, like, it gives the velocity graph, and asks for speeding up and slowing down.
So can you show us?
Velocity and,
yeah, can you show us the graph? Can you show us the graph? It says slowing down and speeding up, or
yeah, it says when is the particle speeding up and slowing down, but don't we need velocity and acceleration to do
no. No, we can also look at the velocity. Or we have to graph the acceleration, or look at the acceleration as well. So let's take a look. So graph of the velocity function of two particles.
I'm just seeing that, and now I'm thinking, is this graph, are the two graphs supposed to be together? But they both say velocity.
So let me do shown where t is measured in seconds. Okay. So it goes up and down. When is the particle speeding up? Using interval notation. So let me just graph that so I can show what I'm thinking of. So I see the graph something like this. Okay. And we have one here, and we have two here, and we have three here. Okay. So you can stop sharing for a second. So this is the velocity. So as you see, the velocity, the acceleration actually. So this is the graph of the velocity, correct?
Correct.
Okay. So the rate of change of the velocity is the acceleration. And when I graph in different points the slope of the tangent line, this is what the acceleration is at this point. This is what the acceleration is at this point. This is what the acceleration is at this point, at this point, at this point, at this point, and at this point. So here it's positive, positive, here is 0, but here is negative, 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 right? So, and the question is, we're asked again, when it is speeding up.
Yeah, when is the particle speeding up? When is the particle slowing down?
Speeding up and slowing down. Okay. So the acceleration here is positive. Here is also positive, but it's smaller than here. And then the acceleration is 0 here. So at the maximum velocity. Right? And then the acceleration is negative, and the particle, so here the velocity, as you see, the velocity is positive on this interval.
Right.
And here on this interval, the velocity is negative. Okay, and now I see your question. Yes, we have to think in terms of both. We have to connect the velocity with the acceleration together.
We have to kind of sketch the acceleration graph.
Yes, just you know, briefly.
Yeah, so it would be like at the x-axis at 1.
So you don't really have to graph it. We just so here at this point, let's say it's 1. Here is 0.5, and here the acceleration is 0, and here I'm going to say is negative 0.5. Here is negative 1, and then it starts leveling off again. So this is less steep. So negative 0.5, negative 0.3. So the velocity is positive on this interval, but the acceleration is positive only between 0 and 1. So both are positive between 0 and 1. But both are negative between 2 and 3. So it's speeding up between 0 and 1 union 2 and 3. Because both velocity and acceleration are negative. So when they're both positive, between 0 and 1 and both negative between 2 and 3, the particle is speeding up. Very good question. Thank you for asking that. But it's slowing down when the velocity is still positive, but the acceleration is negative between 1 and 2. So speeding up two pieces between 0 and 1, union 2 and 3, and slowing down only between 1 and 2.
Got it. Yeah, I was missing that second.
Yes, the second interval, because we have to analyze both. I mean, the entire graph. Yes. Does that answer your question?
Yes.
Awesome. You don't really have to graph the acceleration, but some points, so you see what's going on. See, the slope here is negative, so the acceleration is negative here. Here it's positive. The acceleration is positive, and here is 0. Is there another part of this problem?
It gives another graph, so I'm trying to sketch it out on the graph right now.
Okay. But you have to put it on paper a little bit so you can see.
Yeah, I'm trying to use my snip feature in my computer to try and do it that way.
Okay. Very sophisticated. Okay.
It doesn't look very pretty.
Good. Next question. Anyone? Anyone else? Other questions? What are we working on next? Okay, so let's look at f of x, let's say 2x minus 1 over x plus 3. How do I find f prime of x? Using the definition. What do I have to write? To find f prime using the definition. What is the definition of the derivative?
So we have to do the quotient rule.
That's differentiation rules.
Yeah.
We want the definition. There is only one definition. You can check with differentiation rules, but we are asked to apply the definition. What is the definition of the derivative? It's two concepts put together.
Yeah, it's the
limit as age approaches 0 from the difference quotient 2x plus 2h minus 1 over x plus h plus 3 minus 2x minus 1 over x plus 3 divided by h. Do we know how to do?
Is this?
Chapter 2. Chapter 2. 2.7, 2.8.
Ah, yes. Okay.
How do we do this? What is the next step?
Oh, we'd have to, what's it called? We have to multiply.
Find the LCD. What is the LCD?
It would be the two
Of course,
denominators.
of course. The product of those two. So x plus 3, they have nothing in common. So therefore, the top needs an x plus 3, and this top needs an x plus h plus 3. I distribute x to all three. 2x squared plus 2xh minus x plus 6x plus 6h minus 3. Please remember, two things have to happen, right? So minus 2x squared minus 2xh minus 6x. And then plus x plus h plus 3. Two things must happen. All terms without h must go away. If they don't, like I had that number in there, the 2 or 3 whatever, I couldn't go to bed without taking care of that because it made no sense. So don't drop the limit operator because we haven't applied it yet. So this is limit as h approaches 0. And you see the remainder is just 7h over, and I have to flip h into h, 1 over h. So h, x plus 3, x plus h plus 3. I simplify, and when I plug in h equals 0, I get 7 over x plus 3 squared. So this looks big, but should take you only 3 minutes.
Mm-hmm.
And of course, I'm not going to move on before I check my answer. So I have f of x, which is 2x minus 1 over x plus 3. If I don't get this, I'll say, oops. So f prime of x with the quotient rule, the top prime is 2 and x plus 3 minus the top with parentheses. Do not forget, we have to distribute negative 1 times the denominator prime, which is 1 over x plus 3. If you make the error of simplifying a piece of a term with a factor, the whole thing collapses. So please don't do that. So now 2x plus 6 minus 2x plus 1. It is 7 over x plus 3 squared. So these two have to be the same. This is a very important definition because it tells us what the derivative is. It's two concepts put together. The big concept of the limit and the big concept of the difference quotient. I recommend take those formulas for the volume of this and volume of that. We went over everything in class, but just in case. The volume of a sphere, the volume of a cone, volume of a rectangular box, graphing the function using the first derivative, the second derivative, concavity, inflection points, max min, critical numbers, implicit differentiation, finding the derivative of a function, right, that is given as an integral. Like you had a very simple example. You have integrals, 6 integrals to choose 3. Do not choose more than one definite integral. The other 2 have to be indefinite. Riemann sum on a simple question. Newton's method, you know how to determine that. The derivatives, you have 6 to choose 3. It should take you 3 minutes. That problem, maximum.
I have a general question.
Yes.
So, I remember in last class I was asking you about seeing the test, and you said specific problems you can go over.
Yes.
I was going.
Yes,
I was
any
going
question? Yes, of course. I'm ready.
It's not any question. I actually wanted to know. So I was going through the modules, and it seems like only test 3, like a practice example of test 3, has the solutions, but I don't see that for test 1, 2, and 4. Am I missing it, or did you not upload it for like our discussions this semester?
You mean the old tests?
Not the old test, but like a practice example. Like for test 3, you posted a practice like example for us to do to see how we would do, and then you posted the solutions. I guess like a few like
So
the
it's some old tests. Are you talking about that? I think that's what you mean.
Yeah,
So under modules.
yeah, and under modules it says daily class discussions, and I see test 3 and then test 3 solutions, but I don't see it for the other 3 tests. I wanted to see. I wouldn't know if I was overlooking it or not.
No. Let's take a look. So test 3 and solutions. No, I guess it's they're not there. I'm gonna post an old test with solutions for test 1, 2, and 4.
Okay.
Good.
Okay. Perfect. Thank you.
Very good. Good. Anything else?
I'm working on one of those similar problems to what you just had pulled up for.
Okay, I'm
2.8.
ready. Yes.
And I know everything's supposed to like certain things are supposed to cancel out, and I'm not canceling out enough, so I'm making an error somewhere.
So what f of x?
Yeah, well, f of t, but x is fine. So 3.5 x squared plus 5x. Let me make sure I'm writing it down right. 3.5. Yeah. And so then I did.
Plus 5x. That's it.
Yeah, that's
okay.
it.
So we have
So
f of x plus h first. 3.5 x squared plus 2xh plus h squared plus 5x plus 5h. So this is 3.5 x squared plus 7xh plus 3.5 h squared plus 5x plus 5h. So now f prime of x, two big concepts put together. All this 3.5 x squared plus 7xh plus 3.5 h squared plus 5x plus 5h minus 3.5 x squared minus 5x.
Yes.
So these two go away. These two go away, divided by h. So limit as h approaches 0. H has to be in common from the others because I have to simplify it. So I have 7x. I have plus 3.5h plus 5x. I'm sorry, plus 5. That's it.
Plus 5, yeah.
So now when h approaches 0, I get 7x plus 5. When I use the differentiation rules, I have f prime of x equals 7x plus 5. I have to get the same.
Not plugging in 0.
I have to get, yes, you have to.
That's right. Yeah. Because I was like, I know I shouldn't still have a T and an H, but that's why